Hello students, I am Dr. Stuti Singh from ABES Engineering College and Applied Sciences and Humanities Department. So we are continuing with Wave Optics Part 2. So in the last lecture of Wave Optics Part 2, we discussed about single slit diffraction, and in this lecture, we are going to discuss about diffraction grating, spectra. We may also discuss about missing order, and maximum number of order. Okay, so let us start with the topic diffraction due to end slit. Here, what is the meaning of end slit? End slit is also known as plane transmission grating, or in short, we call it as grating. So in the lab also, you would have done the experiment that from a broad slit, the light, a mercury lamp is kept inside a box with a broad slit, and the light is incident on the collimator that is mounted on a spectrometer, that is a part of the spectrometer, and the grating is also kept on the spectrometer by a holder. This is suppose the spectrometer. And when the light is incident from the collimator on the grating, so whatever the diffracted pattern from the grating we are getting, that diffracted pattern can be studied from the telescope. So this is telescope, this is collimator, this is light source. So light source, over here we have used mercury lamp that gives the white light. Okay, and this whole thing is nothing but the spectrometer. So when the diffraction pattern is formed due to the end slit, that is having 15,000 lines per inch. Okay, that from the telescope we observe that pattern, rotating the telescope left and right, and observing the main scale and vernier scale on the spectrometer. What sort of pattern we get if we come to know is, see, in the light that is not bending by the slit gives a sort of white color in the center. Okay, a sort of white color in the center. And I'm drawing a rectangle because a spectrum is formed. As the slit is also rectangle, so we'll get a spectrum, rectangular spectrum. Then what we get is, on either left and right side, we get a violet. Then we get the whole Vibgyor color. In between, we get, after Vibgyor, we get indigo, blue, green. Also, we get green in between. So I'm not drawing the whole, all the colors, but I'm drawing few colors. So, and at the end, we get red. So this is the whole Vibgyor that we are getting on both the sides. Right here also we get a red color. So we are getting the Vibgyor over here, because when the white light will bend, it will give Vibgyor with the help of grating also. Okay. Again, we can see that over here, the graph that is forming is similar. That there is a central maxima, then there is a maxima. Oh, how I've just drawn it wrong. Let me correct it. Because in diffraction pattern, what is the main condition is that the intensity decreases, right? So let us draw it. And then there is a maxima, and then there is a maxima, and then there is a maxima. So this vector that I've drawn is of the first order. And then second, similarly, we'll be getting the second order on both the sides, right? On both the sides, we'll be getting the same similar sort of pattern. So this pattern we are going to study theoretically in diffraction due to slit. Okay, what is a plane diffraction grating? It is an arrangement consisting of large number of close, parallel, straight, transparent, and equidistant slits, each of equal width. Okay, so the neighboring slits being separated by an opaque region of width p. So that is known as diffraction. And there are almost 50,000 lines per inch should be there in a grating to produce a diffraction pattern of visible light. And that A plus B, the spacing A plus B between them is known as grating element. Okay, so that we in the further also we will be continuing with this. So originally the gratings are made and they're very expensive. So in the labs, we use students' grating. That is a sort of replica of the original grating. So to start with the theory, let us draw the diagram of the end slit. So now let us draw end slit. Suppose this is end slit and the light is incident on the end slit. So the light is incident on the end slit. Let us draw the light source also. Now this is over here, suppose there is a lens kept. That lens is of, in our case, that lens is of the telescope by which we can read the diffraction pattern. So let us draw the lens. And here is the screen XY as usual. So light that will not bend will give us the center C. All the lights that are not bending will focus and will give us the center C. And then from the slits, the light may bend, at an angle theta or theta dash or theta double dash, different angles. The light will bend. Okay, so what will happen? Suppose the light is making an angle theta from the slit. So it will be bending from the different angles. It is making angle theta. This is also making angle theta, theta. And all from the telescope, we can easily found that they can be focused and they will be giving a sort of maximum. Okay, so this is angle theta. This is also angle theta from the slit. So to calculate the path difference, suppose this is M, a maxima is forming. And what the maxima will form, as we discussed, the maxima will be forming this as it is a N slit, but 15,000 lines suppose, white light is incident. So the light that will move straight will give us a white color. Okay, that will give us a white color. And when the light will bend from the slit, then the theta angle, the light will bend from all the slits. And after getting focus from the telescope, we can get the Vibgyor, violet, green to red color. And then it is not necessary that only the light may bend at theta angle. It can also bend from with the help of theta dash angle. Again we are going to get the Vibgyor. This is violet, green to red dash. So now this is first order and this is second order. So which intensity will be more, first or second? As the diffraction is dominating, we are studying diffraction phenomena. So you are totally right that first order will have more intensity. Similarly, on this side also, violet, green to red first and violet, green to red second. Okay. So we are going to find out the positions of this central maxima of this first order maxima, second order maxima, now theoretically with the help of this diagram. Okay. So now every slit over here, every slit over here is acting as a single slit. So what will be the resultant amplitude from every slit? It will be A sine alpha over alpha, because we have also already found out the resultant amplitude in the case of single slit. And over here, every slit, whether it is S1, S2, S3, S4, and so on, like Sn. So every slit is acting as a single slit. So what will be the resultant amplitude? A sine alpha over alpha. This is lens L. This is screen XY. And this is slit, N slit. So correspondingly, we can find out the path difference if we are able to draw a normal from S1 to the rays that are making angle theta. So when we geometrically calculate this, what is the path difference that we are getting? The path difference correspondingly is path difference the path difference correspondingly is A plus B sine theta. Now what is A? Width of transparent area, or the transparencies we can see. And what is B? Width of opaque or opacity. And because the grating is made up of these lines only, the transparent and the opaque line. So A plus B together is known as grating element. So as in the case of single slit, the part difference was A sine theta because there was a single slit. But over here, the part difference will be totally depending on both the width, the slit width of transparency and width of opacity. Therefore, the part difference is equals to A plus B sine theta. Okay, so correspondingly we get the we correspondingly we get phase difference. What is the phase difference in N slit? The phase difference is given by two beta is equals to 2 pi by lambda A plus B sine theta. Okay. So now, when this is equation number 2. So from here, we get that the value of beta is pi by lambda a plus b sine theta. Fine. Okay. So this is the corresponding phase difference that we are getting. The phase as usual, phase increases arithmetically. So with the help of n simple harmonic motion, we can calculate the resultant amplitude, and similarly we can calculate the intensity equation also. So the the corresponding the what we can say the resultant amplitude that we are getting from here is of intensity M on the screen. It is R dash is equals to A square sine square alpha over alpha square sine square n beta over sine square beta. This is R dash square, and the resultant amplitude is R dash is equals to A sine alpha over alpha sine n beta over sine beta. As we can see that intensity equation is R dash square. So this is the value of R dash square. So what will be the value of resultant amplitude? A sine alpha over alpha into sine n beta upon sine beta. Now it is bit differing than the single slit. In single slit, what was the intensity equation? A square sine square alpha over alpha square. Here, this term is also, you can see there's a second term over here. So what does these both reflect? See, the first term, A square sine square alpha over alpha square represents intensity distribution due to diffraction. And sine square n beta upon sine square beta represents intensity distribution due to interference. Okay. So now the pattern that we saw before, this pattern. So the formation of first and second order is due to the first term, A square sine square alpha over alpha square, because diffraction is dominating. But the formation of Bibgyor in that first order and second order is due to the second term. That is sine square n beta upon sine square beta. Okay, so now let us move further. Now we are going to calculate position of maxima in this case. We are going to continue with now calculating the position of maxima. Okay. So let us calculate the position of maxima. So what is the meaning of calculating the position of maxima? If we see that we are talking about this spectra, okay? We are talking about this spectra that is formed with the help of grating. So now we are going to calculate the positions at which all these maximas are forming. Okay. And theoretically, we calculated the path difference, and we also calculated the phase difference, resultant amplitude, intensity. And we saw that in intensity equation, there were two terms. One term was showing diffraction, the other term was showing interference, and by due to which the Vibgyor was forming. Okay, so now let us check the position of maxima. So position of maxima, how we are going to talk is for this, the condition of principal maxima should be sine beta is equals to 0. That is, beta should be equals to plus minus n pi, where n is equals to 0, 1, 2, 3. Okay. So sine beta will be 0. So at the position of beta, there will be plus minus n pi. It means the maximas are forming at 0. Then if you keep the value of 1, then pi, 2 pi, 3 pi, and so on. Okay. So now let us calculate the intensity equation for principal maxima. So we know that the limit of the beta will be n pi. And over here, if we see, then the positions of maximas for forming on the n value of 0, 1, 2, 3. So let us calculate the intensity equation. So for calculating the intensity equation, what we have to do is we will be differentiating numerator and denominator uh, with the we can say with respect to beta. Over here, as we can see that beta is more important, and taking the limit as plus minus n pi. So let us differentiate that. So what is the limit? Limit is beta tends to plus minus n pi, because we are getting the positions at beta, but what will be the intensity? We need to also know the intensity of the principal maxima, or the maxima, or the other principal maximas that are forming. So limit beta tends to plus minus n pi d beta by d beta sine n beta upon d by d beta sine beta. Okay. So when we calculate this, what this become? N cos n beta upon cos beta. This gives the value as n. Okay. So what is the intensity equation? The intensity of principal maxima is proportional to n, because when we will be keeping this value, what this become? This will become the intensity equation is what? The intensity equation is I a square sine square alpha over alpha square into sine square n beta upon sine square beta. And from here, we have calculated the value of sine n beta upon sine beta. Okay, and that is what we are getting. That value is n. So what will be the intensity equation for the maxima? The intensity equation for the maxima will be n square. Okay. So in the case of n slit, the intensity of principal maxima is a square sine square alpha over alpha square into n square. Now what is n over here? N is the number of slits that are present in the grating. N is the number of slits that are present in. So intensity of, if the number of slit increases, the intensity of principal maxima increases. So I is proportional to the n square. Okay, so this should be very clear. Now let us also calculate the direction of principal maxima. Position, we got the position at beta is equals to plus minus n pi. Then we also got the intensity equation for principal maxima due to n slit. And we can see that n is nothing but number of slits. Now we have to calculate the direction of principal maxima, because we theoretically, practically, the principal maximas are forming. So where they are forming, that direction should also be known. So what will happen? What is the value of beta? So if we remember, in the phase difference, we consider 2 beta, right? So what is the value of beta? Pi by lambda a plus b sine theta is equals to plus minus n pi, or the a plus b sine theta is equals to n lambda plus minus n lambda. So what is this? This is nothing but the direction of the principal maxima. If we keep the value of n 0. So what will become? Theta will be 0. This will gives the which order? See, this is also known as grating equation. You know, this equation is also known as grating equation. So what is the grating equation? The grating equation is a plus b sine theta is equals to plus minus n lambda. So n, where n will be 0, 1, 2, 1, 2, 3, and so on. So if we put the values of n, what we are going to get? We are going to get n is equals to 0. We are going to get theta 0. So at theta 0, what is forming? 0 order principal maxima is forming. N is equals to 1. Then what is forming? First order principal maxima. Similarly, n is equals to 2. Second order principal maxima is forming. Okay, second order principal maxima. So again, we can see that we have got the positions or the directions of the spectra of the these are the principal maximas. Now, this is zero order principal maxima. This VIBGYOR is first order principal maxima. Similarly, if other VIBGYOR will be formed, that will be the second order principal maxima. So we have got the position of the principal maximas over here. Right. Now let us continue to calculate the position of minima. Now what we have to calculate? Calculate the position of minima, the minima that is separating the two maximas. Right. Let us calculate position of minima in n slit. Okay. So sine n beta should be 0 for position of minima. But can beta be equals to, sine beta be equals to 0? Yes, sine beta cannot be 0 because if we put sine beta 0, then we are going to get the position of principal maxima because beta is equals to plus minus n pi and that is the position of principal maximas. So over here, sine beta cannot be equals to 0. So if sine n beta is 0 for position of minima, so what is the value of n beta? N beta is plus minus m pi. Okay, and again, if we keep the value of beta, that is pi by lambda a plus b sine theta. So what we get? Plus minus m pi. We are using integer m over here because in beta we have already used n, right? So over from here we can easily see the direction of minima. N a plus b sine theta is equals to plus minus m lambda. Okay, this is the position of now minima or the direction of minima that we can see easily from here, right? Now, so what will be the values of m from here? Now let us calculate the values of m. As we know, in the case of principal maximas, the value of n was 0, 1, 2, 3. Here also we can get the values of m. So what will be the values of m? 1, 2, 3. Can the value of m be 0? No, because if the value of m is 0, then again sine beta will be 0 and that will give the position of principal maxima. The value of m cannot be 0. Therefore, it is starting from 1, 2, 3 and it can move or it can be till n minus 1. But the value of m cannot be 0 or n or 2n or 3n. Why? Because at these values, what we will be getting if we keep the equation at these values, we will be getting position of principal maxima. Okay, position of principal maxima. You can keep the values in this equation. If we keep m equals to 0, we are going to get the theta 0 position of principal maxima. M is equals to n, then again AB sine theta is equals to lambda. We are going to get the position of principal maxima similarly for 2n and 3n. So the value of m cannot be 0, n, 2n or 3n, but it can be 1, 2, 3 and so on. So this we need to take care. Therefore, it is said that there are n minus 1 minima between two successive principal maxima. Okay. Now, since we are talking about diffraction due to inslet, till the calculation we have done of position of maxima theoretically and position of minima, that we are also, seeing with the practical that we have performed in the lab. But you can see that we are not talking about secondary maximas over here. So now let us calculate the secondary maxima and let us see what is the difference between the single slit and end slit for the secondary maxima. So now let us calculate the secondary maxima. As in the single slit, the alpha was very important. And from here, we are knowing that uh, over here, the formation of Vibgyor is important and the intensity of Vibgyor is decreasing. That shows the position of alpha. But formation of Vibgyor shows the position of beta. So here, beta is also very important. So for calculating the secondary maxima theoretically, let us calculate di by d beta is equals to 0. So what we will get is a square sine square alpha over alpha square is acting as a constant over here because every slit is acting as a single slit. So this is the resultant amplitude from each rays that are coming. So this is acting as a this is acting as a constant. So now what will be differentiated? Sine square n beta upon sine square beta. So what we get out of it? 2 sine n beta upon sine beta into n cos n beta minus sine n beta upon cos beta upon sine square beta, and this is nothing but equals to 0, this whole term. So I've already marked 0 over here. So what we are going to get? N, because we again know sine n beta upon sine beta, there are again two terms over here. So sine n beta upon sine beta, we are not going to take is equal to 0. Either this will be 0 or that will be 0. And if we are taking this as 0, then this will give the position of principal maxima and minima. So what will be equals to 0? N cos n beta sine beta is equals to or let us start with minus only. That will make you all more clear. N cos n beta sine beta minus sine n beta cos beta is equals to 0. So now we have written n cos n beta sine beta minus sine n beta cos beta is equals to 0. Because either of the term will be 0 as we discussed before. Okay. So now here, what will this look like? This will look like n cos, if we solve it, n beta sine beta is equals to sine n beta cos beta. That is it. Okay, that is these both will be equals to. Then what will this give the value? This will give the value as very right n tan beta, that is equals to n tan beta. So we can draw a triangle with the help of this value. See, this is 10 n capital N beta, right? So if this is capital N beta, so this is the angle that we can take of the triangle, and we can draw a right angle triangle with the help of N beta as an angle. So let us draw the right angle triangle on the basis of tan N beta is equals to N tan beta. Now let us see. Okay, let us mark the equation numbers. We just, this is equation number 3. This is equation number 4, that beta is going to, beta is going to give us, let us mark the equation numbers, 4. Then this is equation number 5, the intensity for principal maxima, 6. Okay. This is equation number 7 for position of minima. This is 8. Okay, and then this is equation number 9. So with the help of equation number 9, we are drawing a triangle that is having an angle n beta. So if we draw a right angle triangle having an angle n beta, so over here it is 1, and because we can draw the triangle from here, no? So over here it is 1, and here it is, yeah, just every time we have to choose the pen, just wait, beta. Over here it is n tan beta. So what will be the value over here? Under root 1 plus n square tan square beta. Now, why we are making this diagram, you all know. We are making this diagram because uh, finally we have to calculate the intensity, and for intensity again we need to know the value of sine square n beta upon sine square beta, as we calculated for position of principal maxima, where we got the intensity as n square. So here also, so with the help of this triangle, we can find out the value of sine n beta. So what will be sine n beta from the triangle? Tell me. Very right. It will be n tan beta upon under root 1 plus n square tan square beta. Okay. So we can write down that sine square n beta upon sine square beta, that is there in the intensity equation, the second term. From here we can get as n square tan square beta upon 1 plus n square tan square beta upon sine square beta. So when we solve this, we get as n square upon 1 plus n square minus 1 sine square beta. Okay. So now what is this? This is nothing but the intensity of secondary maxima for the diffraction due to n slit. Now over here we are talking about grating. We are talking about n slit. So this is the intensity of secondary maxima, that is n square upon 1 plus n square minus 1 into sine square beta. And where is the, now let us see why we were talking about principal maximas and minima, and now let us see what is the role of secondary maxima in the diffraction pattern due to n slit. Let us check that. So if we take the ratio, if we take the ratio of principal maxima and secondary maxima, I hope we can get the value out of it. So let us take the ratio of intensity of secondary maxima due to n slit and intensity of principal maxima due to n slit. So what will it be? Intensity of principal maxima is n square, and over here also what we are having is n square. So what will be remaining? Very right. It will be 1 upon 1 plus n square minus 1 sine square beta. So from here, if we know in actual grating, what is the value of n? The n is very large. And from the equation, from the equation, it is very clear that if n increases, the intensity of secondary maxima will become weaker. Therefore, being secondary maximas present in the n slit, they are invisible. They are weaker and they are not that visible. So if we draw the graph of the secondary maxima that we cure the spectra we have studied, see. So if we are drawing now over here, what will it be? It will be beta versus I. Okay, this is I and this is beta versus I. So if we draw the graph, then this is the central maxima, that white we are getting. Then there are some secondary maximas being present but of very less intensity. Then there is another principal maxima, then some secondary maximas, then another principal maxima, then some secondary maxima and another principal maxima. Similarly, this side. Okay. Similarly, we are talking about this side. So what is this forming? This is forming the graph of n slit. Now, see on of the beta, if we see beta equals to 0, we are getting, this is your 0 order principal maxima. This is another first order principal maxima. And what is it? This is a Vibgyor. Okay, then these smalls are the secondary maximas present. And again, this is the second order principal maxima, another Vibgyor. So this Vibgyor intensity is less than the first order Vibgyor intensity. So when we say na n minus 1 minima is present, why? Because we can see there are so small or invisible sort of secondary maxima, so weaker secondary maximas are present. So whatever the maximas we are getting due to n slit, all are the principal maximas of different order. Unlike the single slit. In single slit, center is the principal maxima and rest are the secondary maxima. Okay, we can also find out the angular half width of the principal maxima by calculating with an equation. So we can directly write that value over here. I'm giving you all. So the width, this formula is important for numerical point of view also. Width of the nth order principal maxima in n slit will be given by 2d theta n is equals to 2 lambda upon n a plus b cos theta. So from this formula, what we can understand is that principal maxima, the width of the principal maxima is depending on lambda, the number of slits, the grating element, and the angle theta. Okay. Suppose if a plus b is very small, then the angular spacing between the maxima become large. If the na plus b increases, then principal maxima decreases because na plus b is over here. Okay. Similarly, we can find out the other conceptual questions with the help of this formula. So as such, the formula is not there in your syllabus, but to understand the width of the principal maxima, at least you should know the formula directly. And then next was spectra that we are going to talk about. But spectra I've already discussed with you all how spectra is forming in different angles. The Vibgyor is forming. Okay, see, we have discussed just when we were starting the n slit derivation. So I've discussed this over here that another Vibgyor will be found. So now this is only the spectra that we are going to talk about. So if we are going to write for the spectra, you can write about the different orders Vibgyor that are forming due to n slit diffraction grating. Okay, now next. Next is what we are going to talk about, absent spectra. So we have already discussed the spectra. You can see the spectra even over here, as over here a white light, then a Vibgyor and a Vibgyor is forming. So now let us talk about the absent spectra. How to calculate the absent spectra, also known as missing order? Say, in N-slit. Missing order is calculated with the help of grating equation and the direction of minima. Okay, so what is grating equation? Let us take another slide. We are going to talk about missing order or absent spectra. Absent spectra. So from grating equation, what is grating equation? A plus B sine theta is equals to n lambda. Okay, equation number 1. And from direction of minima. From direction of minima. So what is the direction of minima? A sine theta is equals to m lambda, as every slit is acting as a single slit. So over here m is equals to 1, 2, 3 and so on, and n is equals to 0, 1, 2, 3 and so on. So these are the two equations. This is equation number 2. These are the two equations with the help of which we are going to calculate the missing order. Okay. So what we will do, dividing these two equations, what we get is, if we divide these two equations, what we get? Very right. N is equals to A plus B by M. Or M is equals to, or we can say A plus B by A is equals to N by M. Okay. Mark this as equation number 3. I was thinking this or this. Okay, let us mark this as equation number 3. So from it is very clear, if we are dividing equation 1 and 2, what we get is A plus B by A is equals to N by M. Now, let us consider the two cases here. Let us consider two cases here after we are deriving it. See, if suppose B is equals to A, what is meaning of B is equals to A? When transparency width is equals to the opacity width. Okay, this is opacity width, this is transparency width, both are equal. And if we put this value over here, then what we get is, what we get? Very good. N is equals to 2m. If we substitute the value of m over here, then what we get? If m is equals to 1, 2, 3, 4, m is equals to 1, 2, 3, 4, then what is n equals to? 2, 4, 6, 8. So this order, interference maximas will be missing. So over here we can see that sometimes N-slit is acting like a, a sort of filter that is filtering these missing order. And why these are missing? Because these maximas will coincide with the minimas. These maximas are coinciding with the minima. So this will be missing. Similarly, if we talk about another case, suppose B is equals to 2A. Okay, that is the width of the opacity is double that of the transparency. Then what N will become? 3M. So again, when we keep the value of 1, 2, 3, 4, what we get is N is equals to 2, 4, 6, sorry, 3, 6, 9, 12, and so on. So so what is the meaning over here? Then which interference maximas will be missing? These will be missing. And these will coincide with the minimas of this order. Okay. So this is the missing order or the absent spectra that we can talk about. So in the next lecture, we will be talking about maximum number of orders with the diffraction grating, and we will continue with the other topics. Thank you, students.